Here we're going to continue in this video to look at our composite functions. For example, if we have the following, the secant of the arctangent of 3x. Now you'll know this one is a little bit different compared to the ones we looked at in the previous video. The other problems we looked at when we had the arctangent or the inverse function here, we simply had a number here. And here we have the 3x with a variable. So here, when you see this, unless otherwise told, we're going to assume then from this point that the triangle is going to be in the first quadrant. And a lot of times the directions are going to tell you that we're going to be dealing with an acute angle. So if they don't specify any difference, anytime you have a variable listed here with this one as it being 3x, then the assumption is we're going to simply have the triangle in the first quadrant. So that makes things a little bit easier. So now all we have to do is kind of label our triangle. Once again, we're using this arctangent. Well, arctangent, we know that that's dealing with y over x. So here we know we have y over x. And because all we have is the 3x, that's understood to be over 1. So that means our y value has to be the 3x. And the x value is going to be equal to 1. So once again, after we use this arctangent information, we have two sides of the triangle. And now we're going to use the Pythagorean Theorem, which would be 1 squared plus, and be careful, it's the whole quantity 3x squared is going to be equal to r squared. So that means we get 1 plus 9x squared. Be careful, it's not 3x squared, but 3 squared would be, so it's 9x squared equals r squared, which then means we need to take the square root. So we would then end up with the square root of 1 plus 9x squared equals r. And because this is a radius, once again, we know it's going to be a positive number. And it doesn't matter the order that we write this. This is the square root of 1 plus 9x squared. You certainly could write this as the square root of 9x squared plus 1, okay? I think it looks a little bit better if we put the exponent in front, but either way is fine because this is addition and the order doesn't matter. So here we have the radius or the hypotenuse. And now we simply need to find the secant. Well, the secant of our angle theta, well, the secant is the reciprocal of our cosine function. The cosine function is our x value, right? Cosine is the x over the radius, so that means the secant is going to be the radius over our x value, which means we would have the square root of 9x squared plus 1, and that would be technically divided by 1, so therefore we could just certainly write the answer as the square root of 9x squared plus 1. All right, next I want to look at another example of this same type of problem. And I encourage you to actually pause the video and see if you can work this one out on your own. This one's going to be the secant of the arc sine. And this is going to be of x minus 1. And once again, because we have a variable up here with the arc sine, we're just going to go ahead and indicate we have an acute angle, which means we're in the first quadrant. And the arc sine, that is our y value. So we know this is going to be y over r. And that means this is technically x minus 1 over 1. So our y value is going to be x minus 1. The r value, the radius, is 1. So now we need to use the Pythagorean theorem, which is going to be, now this is our x value down here, but instead of using x because we have a variable x, I'm going to use the letter a to represent this adjacent side. So I'm going to call this a squared plus x minus 1, the whole quantity is squared, is equal to the radius squared. Now, of course, when we have a squared plus x minus 1 squared, Keep in mind, if you forget the shortcut, x minus 1 squared means you're going to take x minus 1 times x minus 1, and you're going to have to FOIL that out. Okay, so when you do that, you're going to end up with x squared minus 2x plus 1. And now you can tell that this is why here, when I used a, I didn't want to use x, so it got confused with the other variable. So now we need to solve for a. So if we subtract 1 from both sides, the 1's are going to cancel out. And now I need to subtract the x squared. So if I move the x squared to the other side, that'll become a negative x squared. And the negative 2x, we add it to the other side, so that becomes a positive 2x. And then to get a, we're going to take the square root. So a is equal to the square root of a negative x squared plus 2x. Now, this is okay to leave the answer as a square root of a negative x squared plus 2x. You may see it written this way. Again, because of this being addition, we could switch the order. Having the negative sign in front maybe looks maybe not as clean, you might say. So we could write this as simply 2x minus x squared, and that would be the same thing. So I'm going to write this as the square root of 2x minus x squared. And once again, we have all three sides of the triangle, so then we can easily indicate or find the secant of our angle theta. And once again, the secant is the reciprocal of our cosine. The cosine function is x over r. So in this case, this is going to be r over x. So that means this is going to be equal to the radius, which is 1, over the x, which is the square root of 2x minus x squared. So there we have the secant of the arc sine of x minus 1. So once again, this is the same thing as the previous video, except for now we're looking at what happens when you have an inverse function here involving a variable. And once again, when we have the variables here, we're going to assume that our angle is going to be in the first quadrant, once again, unless something is stated otherwise to indicate where it's located. And the reason we have to do that is because we don't know what the value of the x is going to be, so therefore we are not able to determine which quadrant, so they have to give us some kind of information.